Welcome. You are about to design a gravitational wave observatory in space. If you don't know what this is, I highly recommend the Gravity Inc. videos on YouTube. In under 10 minutes you will learn everything about gravity, gravitational waves, and methods of detection. Gravitational wave observatories shall be capable to detect sources of gravitational radiation, all the way to the end of the observable universe. But there are many technical noise sources that can limit your sensitivity, and the trade-off between mission parameters is quite tricky. The Gravitational Wave Observatory Designer can help. Let me guide you through the features of the designer and show you some nifty tricks. The designer was created using web components, and we highly recommend Chrome or Opera, as other browsers are not fully compatible with this new standard. When you open the designer, you are presented with three options. You can start from scratch with completely blank parameter specifications, or provide a recovery code to modify an earlier design. New users should choose the Load Mission preset option. OGO is an experimental yet quite interesting design study. But for now you should choose either ELISA or Classic LISA. Your choice will pre-populate all parameter specifications. You can have a look at all the details in the next step, and change the parameters if necessary. You may save your work at any point. A recovery code will be displayed that you can use to continue with your design. Maybe most important are the constellation and orbit specifications. The designer is capable to calculate the sensitivity for constellations with 2, 3, and 12 arms. Spacecraft are located at the end of each arm. The distance between spacecraft, the arm length, has many consequences on the sensitivity. Longer arms are more sensitive but at the same time increase the overall noise. All parameters can be given as integer, decimal value, or in scientific notation. You can even enter an array of numbers, separated by commas. When you do that for multiple parameters, each possible combination will be calculated separately. Gravitational wave observatories are usually considered to be arranged in an orbit around the Sun, although Earth orbits or halo orbits were investigated as well. For a certain configuration, and an orbit of your choice, you will end up with a maximum heterodyne frequency of your laser interferometer. This frequency is determined by Doppler shifts due to orbit instabilities, and usually minimized by a sophisticated frequency plan. Laser frequencies are switched many times over the mission lifetime. The longer the arms, the higher this frequency will get. The exact value needs to be calculated separately since it requires a detailed orbit simulation. On the same page you can provide details for the laser systems and optical telescopes. If you need help with a certain parameter, you can always switch on the tooltips in the action bar. Pictures, explanations, or standard values will then be shown when you hover over a parameter. The floating action button will bring you to the next pages. The Instrument tab provides values for the optical bench and the photo receiver electronics. The Metrology tab is all about the phase measurement system and the gravity reference sensors. The Temperature tab lets you specify temperature noise levels. You can generate curves for different locations in the spacecraft in great detail. In the last tab you can choose values for the electrical and optical transmission lines, and provide properties of the signal modulation, which is necessary for a constellation-wide frequency reference. Perfect, you are done. Just hit the action button one more time and name your creation. The designer will now optimize parameters like the waste radius of the laser beams, calculate the magnitude of many different noise sources, and determine the best possible sensitivity for your very own gravitational wave observatory. In the first tab you see the final observatory strain sensitivity compared to other mission studies. You also find an overview of all parameters that were specified. The second tab breaks down all the different noise contributions. You can easily identify the influences limiting your sensitivity. The third tab compares the observatory's strain sensitivity with the usually dominating influences of readout noise and acceleration noise. The final tab shows the characteristic strain amplitude of your observatory, in relation to astrophysical sources of gravitational waves, like black holes and neutron stars. In each plot you can select items in the key, to toggle the visibility of the related traces. So if a plot becomes too crowded, just hide some of the items. You can also click in the plot to display X and Y values for any point. Use the action button, if you want to save the results. It will forward you to a download page. The submission of an author name and affiliation is voluntary. You can download an overview document, that combines the mission parameters and the most significant plots. There is also a zip archive available that contains all plots and the raw data. Or choose the detailed report. It explains all underlying calculations specific to your very own observatory design. Of course, you are the lead author, and may use all the plots and data under Creative Commons Attribution License. I hope you enjoy the Gravitational Wave Observatory Designer. The creators are always happy to receive feedback. Just send an email to designer@spacegravity.org. That's it from my side. See you soon on spacegravity.org. So long, take care, and have fun.